Hello everyone, let's take a look at the third problem of this contest, which is maximum size of a set after removals. If you read the problem, you'll see that we have two integer arrays of even length n, and we should remove n by 2 elements from the first one, n by 2 elements from the second one, and after removal, we insert the remaining elements of num1 and num2 into a final set S, and we want to maximize the possible size of set S. What does that mean? The first time I read this problem, I was like, what do you mean maximize? N by 2 from the first, n by 2 from the second. But then I remembered that in a set, the first two are arrays. Like num1 and num2 are arrays, so you can have repetitive numbers. Like in this example, you have 4 ones. But in a set, repetition is not allowed. So it doesn't matter how many ones you put into a set, you will get only one number at the end because there are no repetitive numbers in a set. So you can get rid of all of the repetitions at the beginning. This is something that comes to my mind. So something I want to mention is that I always try to teach problem solving, not to give away the solution. You can find the solution anywhere, like in comments, in text, anywhere you can find the solution. But how do we come up with that solution is important, because that thought process can help you become a better problem solver, and that is something I want to try and do here. So this is the first thing. So you can get rid of the repetitions here, like so num1 has 1 2 and num2 has 1. So let's go and actually have this and try it. So this is, I'm gonna call them A and B instead of num1 and num2. I don't know why. So this is 1 and 2, and the other one is 1. So we want to take n by 2. In this case, n is 4. So n is 4. We want to take n by 2 from the first one and n by 2 from the second one. But there is something here. Oh, there are some numbers that are present both in the first array, or now set, because I got rid of the repetitions. So 1 is present both in 1 and in 2. So, what do we do? Maybe we can handle the numbers that are in the intersection separately. Oh, so let's have another diagram. Oh, that is a Venn diagram, if you remember. So A, B. So we had 1 in the intersection and 2 here. That's it. That's it. So now we want to take n by 2 from the first one and n by 2 by the second one. So something that is clear probably, or if you think about it, it can become clear, is that we have no problem with the numbers that are here, or a minus b. Problems that are here, we can take them as many of as n over 2. Take them as many as you want. And the numbers that are here, again, we don't have any problem. We don't need to think about them. This is b minus a. We can take as many as n by 2 numbers from this part. So we are trying to simplify the process of picking numbers. So the numbers that are in a minus b, there is no conflict. You don't need to make a decision. Take as many as n by 2 of them. And again, the numbers that are b in b minus a, take as many of them up to n by 2. So what does that mean? That means, so from this area, we can take minimum of n by 2 and the size of b minus a. So if the size of b minus a is greater than n by 2, take n by 2. If the size of b minus a is less than n by 2, take those many numbers. And okay, and do the same here, right? Do the same here. So now we have, let's say, what we have so far. So I'm gonna draw it here. So we have a and b. We have, from this side, we have mean of n by 2 and a minus b, plus the other side. The other side, we have mean of minimum of n by 2 and b minus a. Oh, sorry. Okay. So what happens now? This number could be as big as n, right? This could be as big as n. It could not be bigger than that because of the limit that we have put here. So if it is n, I'm gonna call this x. If x is greater than or equal to n, we are done. Done, because it cannot be great. It cannot be actually greater than n if it's equal to n. Okay, so if it's equal to n, look, let me just make this more. Okay, but what if x is less than n? Oh, okay. So we have some numbers that are still here that we may be able to use them, right? And this is called A intersection B. And we can take as many numbers as there are in that part. And remember, A intersection B represents the unique numbers. So we got rid of the repetition in the first place. So now we can take x plus A intersection B, but this shouldn't be bigger than n. So we should limit this to n. So x plus the size of A intersection B and n. That's it. So you take the numbers from the intersection. So this is the process that we could come up with this solution. Think about the things that we extracted from the problem statement, right array, like set. And then what I did is that I started with two sets. And then I thought, oh, there is some intersection. Oh, I cannot work with the intersection easily. So I came up with the Venn diagram of the two sets. And then I took the ones that are free to be taken. There's no conflict there. And then I took care of the intersection. Let's go and see how we can write the code for this problem. Okay, let's write the code. The only thing that we are concerned about is like A intersection B and A minus B. How do we find that out? So first of all, we should convert them to sets. I'm gonna call this A and B. Set int set A is gonna be A dot begin and A dot end. I have set B, which is B dot begin and B dot end. So we need int. So something here you should notice is that we don't actually want a minus b, we want the size of a minus b. So we need to find a minus b size. I'm gonna write a function to give me the difference. Maybe you can find some built-in library in your programming language of choice. So get difference a, set a and set b, and int b minus a size, get difference set a, set b, set a, and then this is x. If you remember, x is minimum of n over 2. We need to define n as well. N is a dot size, so I'm going to define it here. N over 2 and a minus b size plus min of n over 2 and b minus a size. This is x. We had x here. This is x. And then we need to find the size of the intersection again. So we need int intersection size equals get intersection size of set a and set b. And then we return mean of n and x plus intersection size. That's it. So we just need to implement get difference. So int get difference, what do we have? We have set int a, set b. So to find the difference, we are gonna just simply iterate over the numbers that are in a, and if they are not in b, we are gonna count them. Simple. So int result is gonna be 0 for auto number in a. If this number is not in b, so if b.find number is equal to b.end, that means this number is not present in b. So here we have results plus plus, and then we return results. This is the difference, and we need to implement intersection size. So this is very similar. So we do the same thing, we just do a for loop. This time, if it is in b, we count it. So if it is in b, we count it, and then we return a result. That's it. So let's test this. Compiler error, awesome. Vector. So which line is it? It's line 3, where definition of parameter a. So we have a here. Oh, sorry. This is a, this is b. Okay. Okay, 256, 256. Let's submit. Okay, this is more of a theoretical problem than a programming problem. The programming part is not that hard. You just need to do what is asked you to do, like find the difference. How do you find the difference of two sets? Simple. You iterate over all of the numbers that are in A, and if that number is not in B, you count it. That is A minus B. And do the same for intersection. So, okay, the variation of this problem that comes to my mind is like this. Let me draw something here. Okay, so we have A. We have A and we have B. We want to maximize size of S and minimize Si for sum of Si. So if you have S1 plus S2 plus Sk, which K is the size of S, we want to minimize that. So first we want to maximize the size of S. If there are several options, if there is a tie, we want to pick the one that has the minimum sum of elements. You can solve this problem with the same approach that we used for the original problem. Think about it, and if you have any questions, ask me in the comments.